Well, good morning, everyone, or good afternoon, or good evening, depending on where you're located. Want to welcome you to DataStax's workshop on building Spring applications with Spring Data and NoSQL. And I see we have a number of people online already. Would you let me know in the chat if you're hearing my voice? And this isn't just the normal mic check. This is the first time that I'm presenting a workshop solo, so I just want to make sure that the voice is good. And I see, yes, we are, and loud and clear. Excellent. So, welcome. It's great to have all of you on board. During this workshop, we're going to be looking at Spring Data and Apache Cassandra using our hosted Apache Cassandra service, ASTRA. Good. I'm glad you're not going to bite. Thank you, Kevin. Because I have too many screens to look at, I may not see if you make a comment or something. So I'm kind of scanning as I go through this. But let's go ahead and get started. We'll have a little bit of housekeeping. If you'll take a look, we have at DataStax, we have a number of courses available to you on YouTube, on our DataStax Devs channel, and please make sure you subscribe to the channel so you get updates as we come out with new content constantly. If you have questions, you can ask them in the YouTube chat. We also are on Discord. And our runtime environment for this, we're going to do all of this in online in Gitpod. So if you have a GitHub account, you're able to do this. There is no local install required. Now, of course, if you want to install things locally, you're welcome to do that. But for simplicity's sake, we're going to do everything online. We're not going to have quizzes during this section, so you can ignore the piece about Menti. And I'm going to add one other link up here, and that's, let me see if our bot knows it. Yeah, if you take a look at the chat, the bot recognized the Bang Academy, and we have a number of courses online. They're hands-on with video guidance and quizzes and everything at datastax.academy. So that's sort of our housekeeping and introduction. Let's go ahead and get started. My name's David Chung. I'm a developer advocate here at DataStax, and you can find me. I'm not really a big Twitter user, but I'm online on Twitter at ChungFuCoder. You can connect with me at LinkedIn. I'd love to connect with you and get to know you a little better. And I'm on GitHub at drchung5. By way of background, I come to Cassandra after a long career in the Java world. I've been in the industry about just over 30 years and started working in Java when Java was in beta. I have, some people say, that's a long time. You've done a lot of Java. And the answer is yes. My license plate on one of my cars is Java. And my phone number is 431-5282, and 5282 is a mnemonic telephone code for Java. So my phone number is 431 Java. But the proof that I'm really a Java person through and through is that I have 8 children, and I live in Iowa, in the Midwestern United States, where you can do something like that, have large families. I have 8 children whose names all begin with J. You know where this is going, right? When my wife was pregnant with our 8th child, I suggested that she should be called Java Rose Chung. Since Rose was my wife's best friend's name growing up, I thought, using my thinking cap there, maybe there's a chance. Well, it was at that point that I discovered I'm not really in charge of names. So Josefina Rose Chung, we spell her name the Spanish way, Josefina, is very thankful that, as she puts it, I didn't name her after coffee. But my background professionally, I'm a developer architect. I've spent a lot of time as a trainer as well, working in all forms of Java, from embedded Java to machine controls, real-time, defense and aviation, and of course, enterprise systems. And have come to Cassandra the way many people do. And that is after having spent time in working with relational databases, Oracle, MySQL, MariaDB, and others. And I'm enjoying working with NoSQL, working with Apache Cassandra, but it is a different way of thinking about data. All right, enough about me. Let's go ahead and take a look at where we're headed. This course has 5 sections, and you can go through it sort of different ways. If you are new to the technology, or maybe you're a Python programmer, not a Java developer, so it may take you a little longer to follow some of the Java stuff, don't worry, you can just follow along. The video will be recorded, and all of the materials are available on GitHub. So you can do this stuff at your own leisure. You don't have to follow along with me. You can follow along if you like, or maybe you're an expert and you're just picking up specific things like how to connect to our hosted Cassandra service in the cloud, which is ASTRA-DB. You can do that as well. But there will be 5 hands-on parts using Gitpod and GitHub. So we'll have a chance to do that. I'm just moving my screen so I can take a look at your comments a little better, so it's closer to my eyes. All right. So what we're going to be doing is we're going to be building a service using Spring Data that connects to Apache Cassandra. And this Apache Cassandra we're going to connect to is our hosted Cassandra service running in the cloud. It's our ASTRA-DB. And using Spring Data, we're going to build a REST API that lets us access data stored in Cassandra. So a very common use case for Spring and Spring Data is to build a REST API. And what are we going to do about a user interface? Well, our focus really isn't on the user interface, so we're going to use a common user interface from a project called To-Do MVC. To-Do MVC is a project built by some engineers at Google to showcase multiple web frameworks for building MVC applications. Everything from ASPs to React to Angular to you name the web framework. They have a version of it in this To-Do MVC project. And they expect to connect to backend services using a standard API. There are also multiple backend services available, and we'll connect to one of those and take a look at it as well. So we'll use the To-Do MVC front end, and we'll use a To-Do MVC backend service and connects the two. And then we'll replace the backend service with a Spring Data or a Spring-based service. And we'll use in-memory storage in that Spring service. And finally, we'll configure Cassandra ASTRA in the cloud and replace the in-memory storage in the Spring piece with connections, real connections to our ASTRA hosted Cassandra service. So in the end, once we have everything running, we'll have the To-Do MVC pre-built user interface. We'll have our Spring Data service, and that Spring Data service will connect to ASTRA. So we're not really going to build the front end. We'll use a pre-built front end to make it simple and let us focus on the Spring and Cassandra ASTRA pieces. All right, so that's where we're headed. So we're going to create a to-do application. We're really going to use the existing to-do application. We'll create a repository with a REST API that's going to store data in memory. And then we'll connect, as part 2, we'll connect that to-do application, or really connect the Spring Boot piece in the middle. We'll connect that to Cassandra ASTRA, and we'll have the whole thing running then using Spring Boot, Cassandra ASTRA, and the pre-built to-do MVC front end. So that's where we're headed, and let's take a look. The first thing we'll look at is Gitpod. This application is going to run in GitHub, and we're going to be hosted in GitHub, and we're going to use Gitpod to run it. I'm going to bring up the GitHub homepage, and this is the homepage. Has all the information, or this is the README file, has all the information you need to go through and work on this application. A quick note: there's a trick here that you'll see. In order to prevent the README from being super long, it's broken up into different pieces, and the authors of this workshop broke it up into different branches. So instead of having one massive README file, we have multiple README files. So if I look here in GitHub, I have the main branch, part 1, part 2, part 3, part 4, part 5, and ZEND, or ZEND, for those of you not in the United States. And the reason it's called ZEND is because alphabetically Z comes after P, which was used for part, and we wanted to show that piece up last. So what we're really going to do as we move through the different parts, main, part 1, part 2, part 3, is in Gitpod, we're going to look at the main README, and then for the part 1, we'll switch to the part 1 README. And we're really switching branches within the repo. There's the part 2 README. When I first looked at this, at this workshop, I was trying to figure out how we were switching from part to part, but we are switching across branches. It's a little bit of magic there to make this work and prevent us from having one single massive README. All right, so the first part we're going to, and hello Paco from the Canary Islands, great to have you. We're going to create the to-do application. We're going to look at the to-do MVC framework. We're going to look at an existing front end and an existing back end, and then we're going to create a REST API to a Spring Boot quote-unquote repository that's going to store everything in memory. Later on, in part 2, we'll connect that to Cassandra ASTRA. So this is the to-do MVC project, and you see the goal was to showcase these various tech stacks. And here are the backends. There are backends in Azure and Axon. Some of these I've never heard of. .NET, Django, C#. We'll be using the C# backend. CouchDB, you name it. There's a ton of them. The reason we're going to use the C# backend, and you may ask, why would you, a Java programmer, choose C#? Isn't C# the natural enemy of Java? The reason is some of these backends are hosted or were hosted on a service called Heroku, which no longer does free hosting. So some of these backends are not currently available, and the C# backend is hosted on Microsoft Azure, so it is available and running today. So in this to-do MVC, you can go to this backend index and you can specify the URL of the backend you want to connect to. You can also specify if you want to test a backend, you can go to specs-index.html at todobackend.com. and put in the URL of a backend you want to test. So the top lets us run the MVC app. It's a simple to-do app with a backend, and the bottom lets us test a backend. We're going to do both. When we build our Spring Data backend, first in memory, then later connected to real Cassandra ASTRA, we'll test it. Because there's a set of tests pre-built to make sure that backends meet the requirements or meet the contract of the To-Do MVC API. So we'll do that, and then we'll use a To-Do MVC client and hook up our backend, first our mocked backend and then our real ASTRA backend, and we'll test it that way. So this gives us a pretty cool framework in which to play with these technologies. So we're going to look at the first hands-on piece in GitHub. So I'm going to go to that GitHub repo, and I'll go directly to the repo's base address. So this is the same picture you'll see. And the repo link is in the chat. So when you get to the repo, you'll get to this README page. And we're going to scroll down, and I'm going to launch Gitpod. And I'm going to maximize this. And I'm going to accept the workspace defaults. And this is going to bring up a VS Code in the cloud workspace. Now, a note, at DataStax, we use some variations of Gitpod, and there's an issue in my browser. It seems to be caching some stuff. So you won't see exactly what I see here. I'm going to have to do a little magic to get rid of some of this stuff. You won't see this stuff because you don't have this cached. So I'm going to close these two windows. And I'm going to preview readme.md. And there is an issue that comes up. It's asking about a different Java runtime. Don't worry about that. I'm going to close out the window and the warning. It's not going to affect us. I'm going to preview readme.md. Open preview. And again, this is a VS Code interface. So I'm going to close the File Explorer. And now we have the instructions for our hands-on piece. For those of you just joining us, don't worry if you're not able to keep up with the hands-on. This will be recorded and you have access to the repo later. So you can do this at your leisure, and you will have access to me and others of my colleagues on our Discord channel in case you run into any issues. So we're happy to help you both during the workshop using chat or Discord and after the workshop on our Discord channel. So if you take a look here in the README, as it says, there's nothing preventing you from doing this on your own laptop other than it's more work. You can get the important pieces by doing it all in Gitpod, and I encourage you to do that. So we've already launched Gitpod. We've done this step 1, launch Gitpod, and we're seeing this now. We're not having to import any of the Java pieces. And now it says know your Gitpod. So I'm going to open up a terminal. And again, this is a VS Code interface. So up here in the hamburger menu, those 3 bars, I'm going to say terminal, new terminal. So it opens up a terminal. And I'm going to run this command, gpurl. And in order to paste, because this is a web interface, I have to give permission. So I'm going to allow the paste. And what this does is it gives me a URL that's exposed, that's publicly exposed. We're going to be running Spring Boot. Our Spring Boot application runs on port 8080 inside Gitpod. And port 8080 for my particular Gitpod instance is exposed at this URL. So I'm going to copy that. And what I like to do is I'm going to just open another window to that URL. You'll notice it says port 8080 isn't found. And that's to be expected because so far I haven't started running anything in GitPod. And I'm going to buy myself some more space and just hide my bookmarks bar. So buy a little more screen real estate. All right, so know your Git pod. We've got the URL at which port 8080 will be publicly exposed. Next, we're going to check out part 1. Remember we said that the way these labs progress is not one big README file, but different branches. So I'm going to check out part 1, and that will switch the branch we're working with, and it should update this README. It didn't, so what I'm going to do is say refresh, and it should let me refresh there. That's fine. Now I'll close it and README open preview. And here's my part 1. So we'll open the preview again, and that should be. Now we'll come back to it. I see Aaron has joined us. Welcome, Aaron. All right, so Spring. As I mentioned, I've been working with Java since Java was in beta. And that means I spend a lot of time working in J2EE before it became JEE, and all of that, those frameworks that Sun and the Java community put out there. But if you know the history of Java, Spring saves Java. And Spring made modern Java. The Java Enterprise Edition was too heavyweight, too complex, and Spring simplified Java, and we have Spring to thank for the ongoing success of Java after those early days. So what is Spring? If you are a Java developer, you most likely know about Spring top to bottom. But if you're not a Java developer, Spring is a framework that is based on inversion of control, working with interfaces. And what we mean by that inversion of control is that instead of explicitly instantiating and using things, controlling it from your application says, I want this interface. Okay, well, an interface isn't an implementation. Your application doesn't care. It asks the framework, and the framework provides the appropriate implementation of that interface. That's inversion of control. So here, the traditional application on the left, we have a component implements a greeting service. That's the interface. And the implementation is this component. With inversion of control on the right, in the constructor of this component, we get greeting services, a greeting services reference passed in, and then we call greeting services say hello. It happens to be that the framework will pass in this greeting services. But you might, in a different instance of the framework, you might pass in a greeting services implementation that speaks French and says bonjour or something. So inversion of control, working with interfaces, decoupling implementation from interface and allowing that to be selected by the framework, sometimes on its own, sometimes with guidance from us at runtime. Very powerful idea. There are a lot of pieces to Spring. we'll use Spring to build microservices, and that's maybe the most common use of Spring today. There's also reactive Spring, which allows us to build asynchronous services, non-blocking architecture. So we don't, in Java all along, we've had a traditional blocking architecture. Java services have worked that way since the beginning in the JEE, J2EE days. And the idea was you had a server, a Java server that had some fixed number of threads. Clients would make connections up to that number of threads. So if we had 10 threads, we could serve 10 clients concurrently, and other clients either couldn't get a connection or had to wait for a connection. With the reactive framework, it's asynchronous and non-blocking, so multiple clients can be working with it all at once. There's a lot to that. Spring also has, works in the cloud, very powerful framework for web applications. It can be serverless, event-driven. There's batch stuff, a lot of stuff from Spring at spring.io, but we're going to be focusing on the microservices and web-facing pieces today. Hello, Mohit, and welcome everybody. It's great to see you in our workshop. In Spring Boot, Spring Boot was really a cool framework when it came out and remains to this day, because prior to this time, if you build applications, Spring or otherwise, you had to deploy them inside an application server. And this was Tomcat and JBoss, and I worked with WebLogic Server for many years, an Oracle application server, all these massive, heavyweight, complex servers, and you deployed applications in them. Today, Spring Boot allows us to deploy standalone Spring. I haven't thought of JBoss in years. I'm with you on that, Aaron. Allows you to create standalone Spring applications. No need to deploy WAR files, and what that really means is no need to deploy in a standalone application server. Spring Boot uses an embedded application server, in this case we'll be using Tomcat, to allow us to deploy Spring Boot applications in a standalone environment. And in a microservice environment in the cloud, where we may be deploying multiple service instances in separate cloud compute components, this works really nicely and simplifies things dramatically. So Spring Boot simplifies your build configuration. It also integrates a number of third-party libraries and provides features that we used to have to build onto applications for metrics, health checks, configuration, you name it. Those things are provided for or can be added to Spring Boot applications very easily. So you have the presentation layer, and for our Spring Boot application, that presentation layer is not going to be graphical. It's going to present the services of the Spring Boot application as a REST API using a REST controller. There's the business layer that provides the logic in Spring Boot, and then the persistence layer, which initially will be an in-memory storage, and eventually, as we get to the end of this session, we'll transition to being in our hosted Cassandra ASTRA. And you'll notice the slide says inversion of control between all of these, because each layer is decoupled from the other, and the framework is going to pass references to or create references to the layers. So the business layer, the presentation layer will get a reference to the business layer will get a reference to the persistence layer. It only needs to know about the interface, not the implementation. So pretty cool framework. We've talked about the idea that you have the reactive stack and the servlet stack. So the servlet stack is the traditional blocking request per thread model that I talked about, and the reactive stack. The reactive stack is going to be support streaming. I see Pao, and forgive me if I pronounce your name wrong. Pao has a question about unit tests. What do we really have to test? Why do we do unit tests? We do integration tests directly with test containers. Unit tests are going to be done at a lower level. When I do integration tests, I want to be testing components that should work together. But a unit test is going to tell me that the component works in the first place. So if I do an integration test and something breaks, maybe it broke in the component. Maybe the integration between them is fine, but the back-end component isn't working. So before I test accessing the back-end component, I want to do a unit test to test that the back-end component is in fact working. So a unit test is a smaller test. And it looks like someone is asking a question in Russian, and normally my friend Alex would be on, Alex Voloshev, who would be able to respond to that. I believe it's Russian, looks like Cyrillic alphabet, but I apologize, I am not able to read or speak any Russian, and I don't think my friend Aaron is either, so I apologize, I'm not able to respond to that. So the next thing we're going to do is we're going to move on and look at creating the Spring Boot app, and we'll talk about how that works. So we're going to move back to GitHub. And I'm going to see if I can actually get this to work. So let's see what README. Okay, this is the part 1 README. So I open the preview. It gives me not the part 1 README. I'll get around that this way. Now I should be able to refresh the preview. Wasn't that a slick workaround? But we got it working, so I'm going to go ahead and be happy with that. Okay, and Talhat, your Gitpod says that your JDK is not updated. How do I configure that? Pretty cool answer, ignore it. So go ahead and close the window that's asking for it and close the warning, Paco. And thank you for mentioning that. So I have the part 1 README open. It took a little bit of work to do that. So let's take a look. We're going to run the existing to-do application. Remember, I said that this to-do MVC framework is a series of front-end MVC applications and back-end applications to showcase the implementation, the various implementations, all using a common API. So you can pick an Angular front end and a .NET back end and hook them together. Then you can switch it out for a Ruby on Rails back end if you like. So it's very cool. So you could take a look at todomvc.com, and this is a look at the various backends that are available. As I said, some of these were built on the Heroku framework, which no longer has free hosting. So some of these are not actually live today. But there are a large number of them. And in this workshop, we're going to use this backend, which I said is a C# backend. So I'm going to click on that, and it's going to take a minute to come up. And I see the I love Java, and yes, I love Java too. Now you'll notice this backend returns an empty JSON because there's nothing stored up there right now, but it is working, and we'll show that in a minute. So that's the C# backend. The next thing is there is this spec runner. The spec runner is going to use this backend endpoint and run tests. And part of the to-do MVC framework created these tests to validate that new backends do in fact meet the requirements. So I'm going to use this GitHub command, GP preview, and this is going to, and I think this one is a little bit flaky, but let's do it anyway. What this is going to do is open the test engine, the spec runner, and you see the second half of this URL is the URL of our backend. And this may not work. Yeah, it failed. Okay, and don't ask why. If I take the URL that failed and run it in my browser directly, it succeeds. I'm not sure what magic is going on there, but if you take a look, what it's doing is it's running a series of tests. Does the API respond to a GET, to a POST, to a delete? After delete, can you do a GET? Can you add items? Can you order items? Can you modify items? So it's a comprehensive set of tests for the API. And guess what? When we build the API in Spring Boot, both the in-memory and the ASTRA Cassandra-backed version, we're going to use the same tests to make sure we're compliant. But there was that strange quirk whereby it didn't run in the embedded browser in Gitpod. But if I run it on in my Chrome browser, it runs fine. Not sure what's going on there. So I'm going to close the embedded browser, which didn't quite work. The other thing to note is, so this is the test. This is the back end. We said it was empty. Now if I do this, you'll notice at the back end, there are now entries. You know, title blah, blah, and blah. They're all three titled blah. How'd those get there? They got there because that's what the test did. The test did a bunch of inserts, updates, and deletes, and now you see them in the back end. All right, so we know that the back end works. We saw that it passed the tests, even if it, let's be careful, if I double click on that, it opens the README source. And now we're going to test with the web client. So I'm going to click on the web client, and if you can see that link that pops up, the web client, the second half of that URL, the second half of the URL is the URL of the backend. So we're going to connect to the web client using that C# backend. And you know we're doing it because there are the blah, blah, blah entries. I'm going to add a new entry, foobar. And if I go to the C# backend, you'll see that my entry foobar is there. So the web front end that we've chosen is using the C# backend and really storing data. Someone asked, do you think programmers can be replaced by ChatGPT? Well, what I would say is that some things programmers do can be replaced by ChatGPT. And I don't see that as being threatening. I mentioned being in the industry 30 years. I've actually been working with computers for closer to 40 years. Yeah, so that makes me an old guy. Did a lot of machine language stuff in the old days. And, you know, we used to talk about the weak having to use high-level languages because they couldn't do bit shifting. Well, it's been a long time since I've done any bit shifting and machine language code. And with each technology, more and more of the tedium is being done automatically or automagically, including Spring. So I think there will still be room for programmers. I will tell you a little inside baseball. At DataStax, and I'm sure many companies, we are encouraging our teams to use AI and be smart about it and use it to help us in in our jobs, not just developers, but marketing folks and everybody. So, we are on the cusp of a very exciting, some very exciting changes. And yeah, you could get me distracted pretty easily. All right, so let's go back. So we've tested the README, the to-do front end. And now we're going to create a Spring Boot application. So if you go to the Spring Initializer, and there's no E in Spring Initializer, this lets you specify what you want to include in your Spring Boot application. It lets you specify the version, the extra libraries. You can add a ton of dependencies out here, all sorts of things. Whether you want to do this in Java or Kotlin or Groovy, all JVM-based languages, of course, and then lets you generate the starter project. We've given you a link that has all of these values populated already. So if I go in, here's the link. The group, artifact, and name, the description, the package name, com.datastacks.workshop, the Java version, it's Java 11. This will be packaged as a jar file, which means that it will run on its own. It doesn't require an application server. So don't worry, Aaron, we're not going to be talking about JBoss at all anymore. Last time I'll mention it today, unless someone pulls me into it on chat, but I'll try to avoid it. And we've also specified some dependencies. We want Spring Data for Cassandra, which provides simplified access to Cassandra or ASTRA. DevTools for Spring Boot, Spring Web, which lets us build RESTful APIs. Lombok, which is, for those of you who are not Java programmers, Java does not allow you to automatically create data classes with getters and setters. So Lombok does that. And yeah, Samir, I see, good to see the use of Lombok. Though, even though I'm a Java developer through and through, I'm also a Kotlin developer, and you don't have to use libraries to do that in Kotlin. You can just use Kotlin data classes. And the Spring Boot actuator, which lets you use custom endpoints to monitor things. That's where we talked about some of the enterprise features that you can add into Spring. And then you can generate, and this will download a zip file that creates the Spring Boot project. In our application, we're not going to have you do that because that download just downloaded it to my local machine, not to Gitpod, the environment in which we're working. So we've already done that for you in Gitpod. So in Gitpod, I'm going to change to the directory into which the Spring Data stuff was downloaded. And I'm going to use Maven. And we'll do an install, and you're going to find this fails. Yeah, so it fails because it's not able to do, it's not able to make some connections. So step 3B, we're going to fix that. We're going to have the Spring Boot application ignore a couple errors for now. Of course, ignoring errors is normally not a good thing. Don't worry about it. Later, we'll fix the errors and we'll take the ignore out. So I'm going to use, remember this is a VS Code interface, so I'm going to use Explorer, and I'm going to open the to-do Spring Data application. And it's in source, main, Java, right there. And I'm going to take the Spring Boot application annotation and paste in that these two errors from these two classes, or these two classes are going to be excluded in the configuration. So we're not going to do the Cassandra configuration because we haven't defined the Cassandra configuration or connection information. So now that I've done that, I should be able to run it again. Now we see it passed its test, the one test that's implemented, and it is up and running and listening on port 8080. And if I go to port 8080, you'll notice I get an error page. The application is running and listening, but I don't have a REST controller. There are no mappings to incoming URLs. So yeah, it's running, but it's saying, this is an error because there's nothing, no code that's really listening for anything here. So there's the error page. The author's using the embedded browser. I'm preferring to use the external Chrome browser. And says, okay, we can fix that by creating a REST controller. REST controllers in Spring take HTTP requests and map them to code in Spring. This is a trivial REST controller, and we're going to put this in the workshop hello directory. So the hello directory, which will map to the hello package, and it's called Hello World REST Controller. All right, so there's the file, and I'm just going to copy the code directly from here. And this is about as simple a REST controller as you have in Spring. The purpose of the REST controller is to take incoming requests, and now we have the slash, so any incoming request that matches to that, and we're going to handle it with this function, which returns hello world. We're not yet doing any of that inversion of control stuff to speak of. Haven't built any interfaces. This is just so we have something that responds, because you have no idea how many times I've had people run an application, get an error page like this one, and say the application isn't running. Actually, this error means the application is running, because it's the application itself that's telling you that this is an error page. So the application's running. I'm going to go back. I'm going to shut it down. I'll Control C here. We'll clear, and we'll now run it again with the Hello World REST controller. By the way, if I go out here now, port not found is a different is a different error. Our Spring Boot application is running, and you see when it started, we see the hello world. And I should probably fix this because the original hello world from the Kernighan and Ritchie C book from the 1980s, before some of you were born, I would think, was hello comma world, with like and no space after world. All right, so let's go back and pick up with our README. So we've been able to run that, and the next step is we're going to move to part 2. So we're going to end up checking out, and I'll kill what's running in the terminal. And copy and check out part 2. Okay. All right, so we've looked at the back end and use the client in the back end to connect to the C# pre-built back end. So the client connected to that. We use the specs to test the client, to test the C# back end. And you probably know where this is going, right? Eventually, we're going to use the test to check our Spring Boot backend. First in memory, and then finally connected to ASTRA Cassandra. So the next part is to create the controller. And remember, the controller in Spring Boot is going to map URL patterns to code. We've already created a simple controller. That was a Hello World controller, but that's not really part of our app. We just did that so we could show it was running and how it worked. We're going to create a more complex controller and one that eventually will implement the full API of the to-do MVC. So we're going to switch back. And let's see. That's the part 1 README. I'm going to refresh it and see if we get to the part 2 README. Yes, this time it went right there. So there's the part 2 README. And create a CRUD controller. Anyone know what CRUD stands for? Or where it came from might be a better, I think we all know what it stands for, where it came from. We use CRUD for, to stand for in databases, create, read, update, and delete. And we see that often tied with REST, with RESTful APIs and RESTful interfaces. And slipped my mind the name of the guy who came up with REST, the idea for REST. And if you know it, put in the chat. It comes from the doctoral thesis of one of the key players in the early days of Apache Foundation, and he was responsible for, or influential in, the URI spec, the HTTP specifications, as well as the MIME type specifications. So it's no surprise that his doctoral thesis, which defined RESTful interfaces, uses HTTP, URIs, and MIME types heavily. And a lot of people say, well, RESTful interfaces are CRUD interfaces. And again, the guy's name escapes me, but he will tell you that nowhere in his work does it talk about CRUD. People added that on later. So not something that the founder is fond of, but he's stuck with it. It's the way the rest of the world thinks of RESTful interfaces. So we're going to create a CRUD controller. We're going to look at some sample commands using curl, and then we're going to test the controller. So remember, we went and looked and tested the backend API. That was this. We just went to the URL, and in following RESTful conventions, this should select all to-dos. Or I can specify a specific to-do. By specifying its ID, and that ID is a UID, a universally unique identifier. So that's following RESTful API conventions. So the backend is already a RESTful interface, and when you look at the output, you see something like this. Oops, and that's what we see here. There's an ID, completed as false. There's an order number as a title, and there's a URL for this entry. Okay. Next thing we're going to do is we're going to create a Java bean called to-do, because this is a to-do list. So it makes sense that we have to have to-dos created. So we're going to create a to-do. And that goes in a new package called to-do. So under, let's see, under workshop, new folder, to-do, and new file, to-do.java. And I'm just going to copy the contents. It's a basic Java bean. It uses the Lombok data annotation, which means that it's going to get a set URL and get URL method, set completed and is completed method of following Java bean conventions. So that's our to-do. I'm looking over at the left, and I made a common error in the previous hands-on, and that is I put my hello file in the wrong place. As you'll notice, there are two. That when I switch to this branch in GitHub, it pulled the Hello World REST controller from the workshop, com DataStax workshop hello package. Mine was in the com DataStax hello package. So that's an issue. I'm just going to delete the old one. And it doesn't matter. We don't really need the hello anyway. That was just there temporarily. So now I have my to-do. We'll go back to the README and look at the next instructions. And now we want the to-do REST controller in the same folder. So it's going to be in the to-do package or folder. So I'm going to say to-do, new file, to-do REST controller.java. All right, let's look at the contents. You'll notice we have those methods that we all call CRUD methods. And then we have some Spring annotations, some more Spring annotations. We have our cross-origin settings. So we're going to allow these methods across origin. And we have the request mapping. So this controller is going to listen at /API v1 to-dos. And get requests will be mapped to this method. Gets for a particular UID will be mapped to this method. Post requests mapped to this method. And the request body will be in, oops, if I double click it, brings up the source for the README. And post bodies will be passed in to the method. And there's also a delete mapping for specific or delete, which is a delete all. So that's the let me copy that to do REST controller. Okay, so that's our REST controller, and that's the operations that we need to support. Right now, it doesn't do anything. Returns null, returns null. So we've created that. And now it says, hey, create the REST controller, complete the REST controller, using an in-memory data structure. And the author says a real simple way to do this would be to create a map, because you're going to be retrieving things by UID. So a map with UIDs as keys and to-do objects as values makes sense, and says, so the author says, hey, use a concurrent hash map, mapping from UIDs to to-dos. And the way within these methods to get a URL is you use the HTTP servlet request object and say request get request URL to string, and that returns the request URL. And with that, you can go ahead and build an application. We're not going to take time to do that. There are a bunch of different methods here, and we would definitely run out of time if we do it. So I'm going to cheat, and I'm going to complete both of these classes for you. And if you look here, there's a link to the completed version of them. They're actually in a different branch. Remember, each step of this workshop is in a branch. We're in branch 2 right now, I believe. I think the solutions come from branch 4 or branch 5. But I'm going to pull the solutions. I actually have them in an editor separately. First, I'm going to pull the to-do solution. This to-do is a perfectly valid Java bean, but we're going to add some more functionality to it. Checking for nulls and that sort of thing, and add a couple different constructors to it. But it is essentially a Java bean. And I see Azara Creations is asking about badges. There isn't a badge for this particular workshop. So Nightbot is configured correctly and responding. So here's our Java bean with some extra constructors. So you can construct a to-do using the title and the order. The title and the order and whether it's completed are the possibilities. You can set the URL, get the URL, and then the other setters and getters will be generated by Lombok. The to-do REST controllers, a little bit more complicated. But here's what it looks like now. And we've created a concurrent hash map to map UIDs to to-dos, because we're going to retrieve them and store them by UID. So that makes sense. And for the get mapping, we're going to return a stream of all the to-dos. So we use the hash map, to-do store, values, stream, and then we map it. And here, searching for a specific UID, we're going to call get, passing in the key because our store is a hash map, and we get back a to-do. If it's null, we're going to return a response entity not found. If it's not null, we're going to return the response entity and its URL. And the post mapping, again, we're going to do a put. So a number of operations implemented. Also, there was one other. In the creating a to-do, the constructor, this constructor calls this constructor, and this constructor creates a random UID. That UID, so how does someone who posts know what UID is associated with their insert? And the answer is RESTful conventions say that after you do a create or do an insert, you're supposed to return the URL of the newly inserted item, and that contains the UID. That's why when we did the post, it's going to return the URI as part of the response entity. Et bonjour, elle a dit, bienvenue. Azari, you're saying there's an issue with dependencies. Yeah, there were a couple of flaky things that happened here. One, make sure you didn't do what I did and have two hellos, two hello packages, because I had that error for a while when I was working through this, and it was because I had two classes with the same name and package name stored within my directory structure. Once I deleted the one that was out of place, then the dependencies worked, because it wasn't generating the Lombok getters and setters was the issue I had. All right, so let's go back to the README. We're now going to try to run it. You shouldn't need to create a new app. Okay, now something happened here. It started, and sorry if you don't get it, this might be one you can take into Discord, since I don't have a co-presenter who can answer questions while we go on. Velbov, if that's, yeah, thank you, Zara. It's Visual Studio Code in Gitpod, so it's just an online version of it. So the application compiled and it's running, and it brought this up. The answer is why. Well, it comes back to something we said before. This is the hello. The URL of the RESTful services, and I'm copying it from my notepad off screen, is this. If I do this now, you'll see it's empty. Why is it empty? Because we're using the in-memory Spring Boot application, and we haven't created any to-dos. So I would fully expect it to be empty. It's a good thing it's empty. All right, let's take a look. All right, so it's empty. That's good. And yeah, you see the expected output. Again, I'm not using the embedded browser, but right there in the upper right, gotta remember not to double click on that. In the upper right corner, you see the embedded browser is empty. So here's some curl commands that you can run against it. I'm going to open another terminal, not the one Spring Boot is running in. I'm going to use the plus sign down here to open a new terminal. And I'm going to run this curl command. So you'll see the curl command returned the new entry, its URL, and it has a UID, a title, completed as false, and order is 0. If I go out here now and reload, I now get that single entry. So now we're talking to our Spring Boot in-memory client. And there's a number of other tasks here to get a specific, I'll do this one. This is to return an entry by its UID, and I'm going to copy the UID from above. Oops. I needed to replace the boilerplate code. and it returned the entry as it should. And there are a number of others, deletes and so on. Yeah, Aaron, I think the problem as Hari's having is not directly with the pom.xml. I ran into that, and it was because in the previous section I created the Hello World REST controller in the wrong directory, and then I had two, and it failed in compilation, but it showed up looking like a Lombok error. But there was a lot that went into figuring that out. All right, so next thing we're going to do is we're going to test our REST controller. This is cool. So oh, and by the way, it may not work. And you may say, Dave, you just said this is cool. It is cool. But for me, the embedded browser has been a little flaky. So what this says is gpreview, which means we're going to open up in the embedded browser. Don't double click on it. This URI, todobackend.com specs index.html. That's the test engine. And we're going to pass it the URI of our internal service. So we're using the get pod notation, gpurl 8080/API v1 to-dos. And this is going to run the same test we ran on the C# backend with our internal backend. And we'll see if it actually runs in the embedded browser. It didn't, but have no fear. As I said, the embedded browser has been flaky for me. I'm going to run it here. And you see it ran. So our and how do we know we're testing our own back end? Because we're testing 8080/datasxdev-workshop-getpod.io. That's our back end. You could choose a different back end and throw it in here if you wanted to. But what this tells me is that our Spring Boot backend meets the requirements of this API, even though it's only storing data in memory. And if I go to, let's see, I want to go to our backend. You'll see now, here's the entries, blah, 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 and blah. That the test engine added. So it's pretty cool. Our backend passed the test. That's the goal. We wanted, the API was defined beforehand, and we're building the backend to meet that API. Well, if that's the case, if our backend really works with, really implements the API, we should be able to connect to any one of the front end clients to it. And we're going to do that with this command. So todobackendclient.com/client index.html, and then we pass in that get pod notation for our internal URL. And again, this may not work. It's going to go in the embedded browser. Okay, it did work. It did not work in the embedded browser. And you may say, well, Dave, what do you mean it didn't work? There's a to-do list. The front end worked in the browser, but we don't see the items these items that are already in the backend, already stored. So once again, I'm just going to copy that URL. And now there's the blah, blah, blah. And if I enter a new item, pick up milk at the store, oops, and I want to go to the back end, and there's pick up milk. So it worked. We built that back end piece. We ran the test suite against it, predefined test suite. We met the requirements. So we hooked it up to a front end implementation and used the front end implementation to both view and modify the data stored in the back end. So maybe I want to get rid of the blah and the blah. And I'll go back here. And two of the blahs are gone. So now I just have one action, blah, and another one, pick up milk. So to me, that looks like our middleware piece is working. Now, we're not yet connected to Cassandra. There's no longer, this is all in memory, so it's not persistent. So I'm going to advance to the next part. And let's see, we'll refresh this guy. And now that's part 3. All right, so we're done with part 2. We've created the controller and an in-memory repository. The next part, we're going to move to the cloud. It's actually, it's all been in the cloud, but we're going to move to hosted Cassandra in the cloud, and that is ASTRA. So we're going to take ultimately our Spring Boot code and connect it using Spring Data to ASTRA Cassandra. Spring Data is a really cool part of the Spring framework because it lets us get by and simplifies the connectivity and the mapping from Spring Boot to Cassandra. Cassandra has its own query language called CQL, or Cassandra Query Language. And yes, it sounds a lot like SQL. But for the basic queries, you know, find by ID, find all, delete by ID, delete all, patch by ID, you know, that sort of thing. All those are generated for you. Now, if you have more complex data and more complex queries, then you do have to write some of the code for that, the query code. But for the basic CRUD operations, Spring Data creates those for you sort of auto-magically. So very, very cool piece. ASTRA. Apache Cassandra is, oh, and Aaron, you're going to have to correct me, is it 12 years old, 12-ish years? Just over 10 years, around a dozen years old. ASTRA is what Apache Cassandra would be if it were designed today in a cloud-native world. You can think of it as hosted Cassandra in the cloud. It supports all the features of Cassandra, shares a lot of code with Cassandra. And the benefit is it runs in the cloud. It's managed for you by DataStax. It does eliminate operations. I would say it's low ops, not no ops, but low ops is a good thing because there's a lot that goes into Cassandra operations. I come from our service team, and our service folks spend a lot of time helping customers. Yeah, so about 12, 13 years, helping customers with the management of Apache Cassandra and Kubernetes and VMware, you know, all kinds of things. ASTRA allows you to let DataStax do that for you in the cloud. It's secure, it simplifies development, and reduces operations. It's also cloud agnostic, vendor agnostic in the cloud. You can have hybrid clusters crossing cloud boundaries. So you could have an Azure and GCP cloud if you want. You can have data centers in different locations, take advantage of regions or zones within your cloud vendor space. So a lot of cool features of ASTRA. ASTRA also has a number of ways to access it. There is a framework. You see the top icon here under DevTools. There's an API called Stargate. And Stargate is an open source API that sits on top of Cassandra or ASTRA and allows you to access it a number of different ways. It allows you to create a REST API. It allows you to use GraphQL. It allows you to use a document API if you want, and there are others, and a growing list. It also has a built-in console, so you can run CQL commands directly through the ASTRA graphical user interface. So let's take a look at the database part, ASTRA. I'm at ASTRA, that's astra.cassandra.com, and I'm going to sign in. All right, and I'm going to go to step 3. So step 3 is what we're going to do. We're going to go to astra.datastacks.com, and you can create an account. I'm using my personal account with my email, but you can use GitHub or Google. ASTRA has free usage up to a limit. You get a monthly usage credit, and the nice thing is, you do not need to register a credit card. This is not an opt-out. After 30 days, you have to opt out or you end up paying. You won't accidentally cross the usage threshold and start paying. If you cross the usage threshold, we're of course going to ask you and invite you to pay, but we will not, at DataStax, will not keep your credit card information. So there's no danger of you running up a bill by doing this. In fact, I work for DataStax. I have multiple ASTRA accounts for workshops and exploration and all that. And DataStax doesn't have my credit card. So don't worry about it. It's a pretty cool deal. When we get there, we're going to create a database. It's going to be called MyFreeTierDB. You can actually call it what you want, but that's what the lab suggests. And the key space, we'll create a key space called to-do key space. A key space is similar to a schema in a relational database, and it is a grouping of tables and some other things like user-defined types. But a key space allows us to organize things within a database. We'll also choose a database provider, and depending, there are different providers available for the free tier, and then if you were in a paid tier, there's a larger set of providers. We'll then create the database, and you'll see the database is pending in the dashboard. So I'm going to jump right to that and do those steps hands-on. Now, I already have a database called My Free Tier, so I'm going to create a different database. I'm going to click on Databases, Create Database. I'll call it My Dummy DB. And the key space dummy. It's in the Google Cloud, and I'll choose a region. And for those of you, especially those of you outside of the United States, I'm based in Iowa in the central United States, and you've probably never heard of it. But anytime I see Iowa, you've got to stand up for my state. So I'm going to choose the U.S. Central 1 region from Council Bluffs, Iowa. There's a data center there. Actually, there are a lot of data centers in Iowa because the costs are low, electricity is inexpensive. And you see the operation costs are going to be different for each region. But 36 cents for a million read requests. Yeah, I think we're not going to spend $25 worth. So I'm going to create it. All right, it's going to take a minute for it to create, and you'll see its status is in pending. I'm going to switch over to the database that I already have and just show you some of the features of ASTRA. There is an overview, and this tells me about the database. It tells me the ID. I can do things like, I can get more details and so on about it. Tells me about the key spaces. I have one key space, the to-do key space, defined. I've just had a few read and write requests. It's just a toy database. Oh, Bob, I see you were in Des Moines for a few months. Nice. Worst weather in the world. We have cold winters and hot summers, and it's humid when it's hot. But we like it here. There's a health tab, and this gives me some monitoring in Grafana. So we'll look at requests, errors, latency, size, number of things, clients or no clients connected currently. But I can set a refresh time for data. I can set, how long I would look the last 7 days, or, I can set up how I want to view data. We'll come back to this one. This gives me information about connecting. And I can choose different ways to connect, APIs, drivers, SDKs. Other. And Vaibhav asks, do we have observability addressed through this ops dashboard? The answer is yes, but ASTRA is multi-tenant. So there are some bits of observability that you don't have because it would give you visibility to information possibly about other tenants running on the same on the same nodes. ASTRA is serverless. Of course, there really are servers. It's not actually serverless, but you don't have to worry about servers. One of the things in self-hosted Cassandra is if you need to grow your cluster, it's up to you to bring new nodes online. And there's a process involved. Or worse, if you have to be elastic and shrink and grow based on maybe seasonal demand, it's a process to grow the cluster. It's a process to shrink the cluster. Since ASTRA is zero ops, or as I prefer to say, low ops, you don't have to worry about any of that stuff. And it acts as a serverless server. There's also a CQL console that's going to let us run queries and commands directly in the database. ASTRA also supports streaming. And there's a ASTRA streaming, that looks like the wind blowing, ASTRA streaming down here. And it supports a hosted Pulsar service for change data capture as well as general streaming. So pretty cool, pretty powerful framework. All right, our database is up, MyDummyDB. And in order to connect, you're going to need to have some information. There are two things you're going to need. You're going to need to get a bundle, which is a zip file that contains information like the SSL and TLS stuff you need to connect. So that gets that gets downloaded. And then you're going to need a token. The token is going to provide the credentials to access the database. I'm going to show you how to generate a token, and then I'm going to delete this database because I don't want there to be a video out here on the internet of real tokens to access a real database. So you generate a token, and here's the token. You get a client ID and a secret, which is like a username and password, and then a token. And you can't even see all of it on the screen because you'd have to scroll to do it. But in real life, what you would do is copy or download this information in order for you to do the exercise or to work with this on your real application. I'm going to close this. I'm going to go to my DummyDB, and I'm going to delete this database altogether. Terminate. And now it's being terminated. All right, so I got a token, and here's an example of a fake token. And I showed you how to create one on the screen, and I deleted it. The Secure Connect bundle. You go to the Connect tab. The user interface has changed a little bit since this. You don't have to pick Java. So if I go to my free tier DB, connect, get bundle, select a region, US Central 1, and now I can download the bundle or the URL for the bundle. In the lab, you're asked to download the URL for the bundle. And I'm going to copy that URL because there's something worth noting here, I think. Actually, it's the curl. I'm going to copy the curl command. All right. But the token and the bundle are necessary to connect. So I'm going to go back to the README instructions. And it says, use this curl command with your link to download the bundle into temps creds.zip. So I'm going to paste the curl command that I got online, and I'm going to modify it. And yeah, it takes a minute. As you'll see, this curl command says curl-o, and then it's going to store it in secure connect myfreetierdb.zip. I want to store it in temps creds.zip. So I'm just going to change the URL. Or excuse me, I'm going to change the local file path in which to store the creds bundle. All right. Temp. Okay. It's downloading, and now I'm going to take a look at it. ls-l temp/creds.zip, and I see the file is there, and it's not zero size, so that's roughly the right size, 12374, 12270, close enough. All right, the next thing I'm going to do is I'm going to configure the application properties to use this information. And I'm not going to show it to you because the actual values are real credentials. But I'm going to set the path to and these credentials are for a database that no longer exists. I am going to set this to temp creds.zip. That's the bundle. There's some Spring configuration, Spring data configuration. The key space is the to-do key space. And I'm going to use my real username and real password. So I'm going to, excuse me, I'm going to do that off screen. And let me get my username pasted in. And my password or secret. Paste it in. Close the file and bring it back on screen. Okay, so I've modified the file. And now I'm going to run a test. This test is just checking to see if we can connect to ASTRA. So it's really checking if the credentials I pasted in and the path to the cred zip bundle are valid. So we'll let it run. No POM file, I'm in the wrong directory. I can do an ls-l and just check. And there is no POM file, so I need to be in the to-do backend Spring Data directory. There is a pom.xml here, and that's the build file for Maven for those of you who aren't Java developers. So now I'll run the Maven test. And I'm really hoping it makes a connection. Compiled, that's a good sign. Test, now it's running the test. All right, one test ran, no failures, no errors, no tests skipped. So now I know that it makes a connection. The next thing we're going to do is run create schema and ASTRA test. What that really does, let's see, I'm looking for the source. There's tests, create schema. What that's going to do is create the schema. Uses the Secure Connect bundle, passes the credentials, uses the key space name, starts a session, and uses the schema builder to create a table and set the data types and column names. And no surprise, the data types and column names, which are defined in the to-do entity class. Well, we know what those are. They're the column names: to-dos, UID, title, completed, and offset. So what this command is going to do is actually create the schema in the database. We first tested to see if we could connect. We can, so we should be able to create the schema. And in response to the earlier question someone had about unit testing, I might have written these in the same, as different operations in the same unit test file. And another way to do it. So there'd be two tests. The first would be a connection test, and the second would be actually asking it to create the table. All right, so it ran, and what that means is the table should exist. So I'm going to go back to ASTRA. I'm going to go to my database, my free tier DB, go to the SQL console. All right, and I'm going to say, I'm not quite following the commands as the author said, but I'm going to describe key spaces. And I see a bunch of key spaces. All of those are system key spaces except to-do key space. That's the one I wanted. And now I'm going to use the key space, just like you'd use a schema in a relational database. And I'm going to describe the tables in this key space. And there's one to-do table called to-dos, and I'm now going to describe that table. So here's the table. It's in the key space, to-do key space, names to-dos. Its primary key is a universally unique identifier called UID. It's got a Boolean called completed. Offset, which is an int, and title, which is text. And offset is order in the other places we referred to it. So the table was created successfully, and that was the goal of that test file, to create the table. And it says describe the key space. I did it a little differently, but same basic idea. The next thing to do is to connect the application to ASTRA. So we're going to create a folder called conf, and it's in comdatastacksworkshop.conf. So a conf for configuration folder, and in it we're going to create a file, Spring Data Config. The Java file. Create that file. This says it's configuration information. This is kind of cool. This is part of the magic that Spring does. We have a reference to the secure bundle. Well, the bundle is a file in the file system. Normally, if you wanted to do something with the file, you'd have to go and load it and stuff. But Spring lets us specify the path from the properties file, and then Spring is going to load it. It's going to inject it and load it automatically. And then we're going to create the session builder bean, and that's going to be used to allow the to-do application or the to-do web service, if you will, or RESTful service. It's going to allow that to connect to ASTRA using the connect bundle and so on. So a lot going on in a very little bit of code, and that's one of the beauties of Spring. So we've got the config file. Next, we're going to create, we're going to go into the to-do backend Spring Data application class. And we're going to remove these excludes. Remember, the excludes were there because we weren't actually connecting to Cassandra. Now we are. So we'll remove that information because now we're going to make a real connection. So there won't be any errors around it. And now we're going to run another test, another unit test. And this is to make sure that the context loads. Before, we were really just testing to make sure that we had the right properties, and then cheating and using a test file to create the database. Now what we're going to do is test the application and make sure the application can connect. We know the test can connect, but can the application connect? And the tests ran and no failures. So the application can connect, our information is correct. And now we can run the application. We'll let it finish its startup routine. And thank you so much, Aaron, for jumping in and responding to questions. All right, let's see. Build failure. Oh, port 80 was already in use. Okay, that's a simple one. I have another shell that's running in. I can switch on the right between terminals. So I'm going to go to this terminal and hit Control C. And I'm going to use a trash can to close that. Now let's start it again. It should start up fine. The nice thing about Spring is that Spring does a lot of the busy work for you. All of the connecting stuff and keeping track of that, Spring largely manages. That's pretty cool. Okay, so that's our test. Here's our application. And it gives us an empty result. But that makes sense because we don't have any data yet. We just created the table in ASTRA and we haven't populated it yet. So I wouldn't expect to see anything here. So as expected, that's a good thing. All right. I'm going to shut that down just because if I don't, I'll forget and run into the same problem later. I might try to restart something. And that brings us to the end of part 3. I'm going to run those commands to switch branches. And I'll open the preview of the README and see if it opens to 4. No, it didn't. So it's a little bit flaky about that. Now I'll refresh the README over here. And it changed to part 4, and I'll close the source. Not sure why it's doing that, but so be it. Okay. So we've created the repositories. A little bit about the data modeling in Cassandra. If you have an application and a data model that gets stored in the database. The queries for to-dos, we want, and our API already supports these because we've tested it. It lists, you can list all the tasks, list a specific task, create a new task, mark a task as complete or incomplete, delete a task, delete all tasks. That's kind of the features that are a part of this to-do MVC application. In Cassandra, and this is one of those places where relational databases and non-relational, specifically Cassandra, are very different. As I said, it's a different way of looking at data. In a relational database, what happens is you start with a conceptual data model, and eventually you build, through the steps, a logical and physical data model optimization. And in relational databases, you tend to get very stable data models. I worked for a large US bank, and I was building internal web applications for our mortgage team, and new requirements would come in for us. Very rarely did they require a change in the data model. Good thing, because changing the relational data model was a process. Our data modeling team was located halfway across the country from us. We didn't know anybody personally on the team. If we wanted to change a data model, we had to file a JIRA request and set up meetings and go through all these gates to get it done. It took a long time. Now, the good thing is we had a very good relational model. And if the data's in there in a relational database, you can come up with some query to retrieve it. May not be super optimal, but you can do it. In Cassandra, it's just the opposite. In Cassandra, our data model is tuned to support specific queries and to support them at a low latency, high volume, and high availability. So that's what you get: low latency, high volume, high availability, and queries, data models specifically tuned for specific queries. Nothing's free. If you want different queries, you often need to modify the data model. It's not like a relational model where you create a great model and just use it, new queries, whatever. No, in Cassandra, the data model and the queries are designed to go with one another to give you that high performance, high availability, and internet scale. So in Cassandra, we start with a conceptual data model, just like you would in a relational database, but we also look at what we call the application workflow or queries. So what queries will run against this model? Then, once we have those two inputs in parallel, we can create a logical model and ultimately a physical model. Now, the task database is super simple. It's got 4 fields. The primary key is the UID. It's got a text field for the name of the task, a completed field, which is a Boolean, and an offset or order field in case your tasks are ordered. And that's it. Just a side note, this particular table is not an ideal use case for Cassandra. Remember what I said Cassandra gives us, and that is super low latency, super high availability, and global or internet scale. My to-do list has no more than, I guess I could get to 100 items for my personal and work and other to-do lists all combined. I might get 100 items, maybe a couple hundred. I'm never going to have 1,000. I'm never going to have a terabyte worth or a petabyte worth. So yeah, maybe Cassandra is a bit of overkill, but it's a great example to demonstrate Cassandra. I will tell you that the primary key here is a single field, the UID field, and that doesn't take advantage of the partitioning of data in the way we normally do in a Cassandra application. I'll leave it there. It's a much bigger basic discussion about how Cassandra works in data modeling. And you can take a look at DataStax Academy at our data modeling course and really get the details on how that works and why. So that's the model. You have the user interface at the front end. You have the API in the middle, and we're showing it with a Swagger interface. We're not going to get to that today, but you could. And then you have a driver that connects to the database, or we're going to do that through Spring Boot or Spring Data and a driver. There are DataStax drivers for a number of different languages. And I mentioned Stargate that gives us different APIs to access data. And in ASTRA, the Secure Connect bundle is going to give us information on the connection. How do we know where to connect? We didn't give any URLs because the Secure Connect bundle has them. And then the token generated the username and password information. So we open a session using the Secure Connect bundle. We use the key space and we provide the credentials. All of those were hidden in the properties file that I didn't show you. I kept that off screen so those credentials, that real database, wouldn't be exposed to the world. So connectivity, in Spring Data, let's see. It looks like we're going to run a couple minutes over, so if you'll bear with me, we'll get there. We've already actually done parts 3.2 and 3.3, which is connecting to the database. So in Spring, there's a number of pieces, but we have the controller layer that exposes the data to the world. We have the service layer in the middle and the persistence layer with the DAO and repository. So we need to put these parts together to make Spring Data work. And you can use Spring Boot and Cassandra, Spring Data for Cassandra, or you can use it without it, and then you have to configure the drivers and all that yourself. So this information was in that properties file. It's the Spring Boot configuration for Cassandra. Samir asked a great question. Is Cassandra ACID compliant? And Aaron has a great answer. The answer is it will be in Cassandra 5. And Aaron has a couple of videos on that on YouTube. And maybe, Aaron, if you're still listening, you might want to share the video for the channel on that. But yes, it's coming. We are excited about it. And Aaron has a great explanation in video and other format available on YouTube. So this is the Cassandra configuration. And in Spring Data, you have an entity class, which defines the data type. So UID, title, complete, offset, and that's the task type. And we have to map the primary key column and say what it is. And then you have the repository. Here, we've provided a specific query, select star from to-do tasks, where UID is equal to the value passed in. But we're going to make it even easier than that. We're going to let Spring Data generate the find by primary key method, essentially what that is. And Spring Data will do that automatically. So the next part 4, is the last part. And we'll switch back and look at part 4. So part 4, object mapping, creating the repository, unit test, and plug it in and make it work. So the object mapping is going to take the to-do entity and map the object, which is the Java class to-do entity. I double-clicked that again. It's going to map that to columns. So the UID column is a primary key, and the column name in the database is column_UID. And we're going to do all of those. So I'm going to open the to-do entity class. And replace it with that, and that's adding the extra annotations, the Cassandra mapping annotations. So the primary key, this is the name of the column of the database, this is the type name, and the other columns. All right. Next, I need to create a repository. And there are 2 ways to do it. And I'm going to go for the simple way. One, the harder way, you can create it and do the connection stuff yourself. Or you could create a class, or you can simply create an interface. And this is, again, where that Spring inversion of control comes in. You can create an interface, specify that it extends the Cassandra repository, specify the types, to-do entities, and the primary key type is the UID. That's a repository. So I'm going to do that. And in the to-do folder, I'm going to create to-do cassandra.java. And the author says use getpod to help you with the imports. You have to import repository, Cassandra repository, to-do entity, and UID. I'm going to cheat because of the time. And I'm just going to copy that information in here into this file. So it's just these imports that were necessary to make this work. All right, that's the repository. Oops, went back too far. There we go. And I'm going to unit test the repository. So to do backend Spring application test class, the unit test now is going to create a new entity and use the repo to store it. So pass unit tests, first tested connectivity, then created a table. To do backend Spring application data, it's that one. It's not that one. Let me get the right one. Application tests. Here we go. All right, so this should actually create an entity. So that's a good test. Okay, this is similar to the issue that someone else was having before. In Lombok, it says there's a duplicate class, competencies workshop Spring config. And the problem is that this class exists in two places. And I know it goes in the workshop subdirectory, so I'm going to delete it here. I'm not going to analyze how it got there, but I might not have been careful in one of the previous sections in following the author's instructions. So let me run that again, and we're getting real close to finishing up here. Sorry to keep you longer, but I appreciate your hanging on. Because now this should, once it runs, it should go ahead and do an insert into the real database. And we'll check that database. Okay. Oh, I know what's wrong here too. The application properties files no longer, when we changed the branch, the application property files no longer has the real credentials, the ones I didn't show you. So give me just a second. I will change the credentials and then it will run. And I guess that makes me an optimist. Okay, close that file so those don't get published. And let's clear and run. Should now be connecting to the real database. Okay, it succeeded. Now let's just make sure. Trust but verify. I'm going to connect to ASTRA. I'm going to go to the SQL console. I'm going to use the key space. And we'll select, and there it is, simple task 1 that was inserted by the application. So good, that worked. Okay, and we tested it, got that. Next comes the magic, because we still have our REST controller needs to now use the Cassandra repository. So HTTP requests that come in will be mapped to methods that interact with the Cassandra repository, which interacts with the ASTRA instance. And the author says, here's how you start doing that. Here's a snippet. There is a link if you expand this to the solution. I'm going to, I'm just going to go and copy the solution into the REST controller. So there's the to-do REST controller. And I will show you some of the solution, a little more than the author showed you there. Okay, so there's the completed to-do REST controller. And now you'll notice it's got, there's the repo reference. And how does it get the repo reference? It's passed into the constructor. Well, wait a minute, who constructs this? The Spring framework. So who provides the repo instance? And the answer is the Spring framework provides it. That's the magic. That's the inversion of control and injection that's going on. And now the data, instead of getting it from the in-memory hash map, we're getting it from the repo. Or in the case of a post, we're saving it in the repo. So this is what connects everything together. And you were asked, you were given sort of the skeleton of this and asked to complete it. I just pasted in the solution for the sake of time. And now let's run it. Okay, it's running. And I see the sample task. This is now running from, or get it directly from ASTRA. And now I'm going to test, and I'm not going to use the built-in browser. Remember, I was having trouble with that. I'm going to copy the URL and run the unit tests against my ASTRA-based Spring Boot service. I've got to put a real URL in there, so let me copy the URL. There, I'll put the URL in that way. That's working. My ASTRA-based service is running and passing the tests. And as I said, I want test but trust but verify. I'm going to go back to ASTRA. And if I select from to-dos, you see it's deleted some, or it's modified some, and it's added the blah. So we know we're really talking to ASTRA. And then I'm going to bring up the client side, because ultimately said we were testing this using this client. I'm going to copy the URL to my backend, my REST backend. And remember, these two didn't have names. And there's blah. what needs to be done. Thank everyone for attending. And let's check. Did that get entered? Thank everyone for attending. All right. Well, I want to thank you all for attending. And Aaron, thanks so much for answering questions on the chat. I probably wouldn't have been able to do it while I'm going through and doing this. Some resources, datastax.com/dev. Our workshops are here, and the DataStax Devs YouTube channel that you're on. Go ahead and subscribe to the channel. You'll get notifications when we have events coming up, and we try to do those fairly often. And also I mentioned Academy, and I think Nightbot knows Academy. But Academy, or datastax.academy, where we have free courses and we have a list of courses that'll be growing. And when Cassandra 5 comes out, you heard it here first, when Cassandra 5 comes out, Academy and our associated certifications will be updated for Cassandra 5 when Cassandra 5 releases. So it'll be a great place when the new version comes out to learn about all the cool new features and to update or get your first Cassandra certification. But thank you for attending, everybody. Really appreciate it, and have a great rest of the day. And thanks again, Aaron, for the help. We'll see you all later. Bye.